Hi everyone. This lesson is a continuation of the Conic's test review. So this is part 2 to review for the Conic's test. So let's get started. So the first question that you're going to see says, or number 11 says, name the conic. Write the equation of the conic in standard form. List all the components. What this looks like to me right now is a hyperbola because it has y squared and it has x squared. In addition, it has a minus sign. So that's telling me they've already completed the square for this problem, but it's not in standard form because of this 9 here. So we do need to divide through by 9 on all of the parts. And that's dividing by 9 is the same thing as multiplying by 1/9. So that's what we're doing. So I'm going to rewrite this. I'm going to put the x squared term first. I know a lot of people like to put the y squared, which is the positive term, in this problem first, but I like x squared first. So this is over 9. We have plus y minus 2 quantity squared over 36 is equal to 1. We have a center at 3, 2. So we're going to go over 3 and up 2. In the x direction, you look underneath x. So in the x direction, you're going to go the square root of this value right here. So you're going to go 3 to the right, and then you're going to go 3 to the left. In the y direction, you're going to go the square root of 36, which is 6 up. So 1, 2, 3, 4, 5, 6 up. And then you're going to go 6 down. And because this is not an ellipse, if this was an ellipse, I would connect all the dots. But this is actually a hyperbola. So what we're going to do is we're going to make a box down here like this. And then we're going to put in our asymptotes like this. Okay, like that. And from here. Okay, from this center point, which is at 3, 2, from that center point, you would go up, you rise up 6 over 3. 6 over 3 is 2. So from that, you would be going 2 over that. So from this point here, your equation would be, of your asymptote from this point would be 6 over 3x. Plus or minus, because you would go up 6 over 3, up 6 to the left 3, down 6 to the right 3, etc. Now, because my x squared term is negative, that means this term right here is my b squared. It means this term right here is my a squared. It means that because the y squared term is positive, that my hyperbola is actually going to follow along my asymptotes this way and also this way. It'll be on the y-axis. Additionally, my focal points are going to be used. I'm going to use this equation, c squared equals a squared plus b squared, to find my focal points. So you're going to go c squared is equal to 36 plus 9. That's 45. So I'm going to take the square root of 45 is equal to c plus or minus. So that's going to be equal to plus or minus, breaking this down, that's 9 times 5, which is 3 root 5. So 3 root 5. Now, because I know that my focal points are up here and down here, like that, cupped within my my arcs of my hyperbolas, I'm going to add this value to my y coordinate right here. If my parabola or my hyperbola had done this, like that sideways, I would have added this term to the x coordinate. Okay, so what we're going to do here is we're going to say the point of my foci are now 3, 2 plus 3 root 5 and minus 3 root 5. Okay, so those are the equations of my foci. The next question says, find the focus point of the parabola. So what I see here is this. I'm going to rewrite this so that my squared term is on the right. So I have negative 16 times the quantity x minus 4, quantity squared, is equal to y plus 2 quantity squared. Remember that I understand some people do like this term, that's your 4a. However, I do use this here. My equation that I use is this, x minus h is equal to 1 over 4p equals, 1 over 4p times the quantity y plus 2 quantity squared. And what this value is right here, or y minus, let me rewrite this. If I were to just put my general form, it would be x minus h equals 1 over 4p times quantity y minus k quantity squared. So this would be my general my equation in standard form of my for my parabola. However, using these values, you'll notice that there's no term in front of this x. So I do need to get rid of this. I'm going to divide that out. So by doing that, I'm going to end up with x minus 4 equals negative 1 over 16 or times the quantity y plus 2 quantity squared. My vertex for this equation is at positive 4, negative 2. It's always x, y. So you're always going to go x and then y. Now, the middle term right here, this term right here, is my 1 over 4p. So I'm going to rewrite that and say negative 1 over 16 equals 1 over 4p. I'm going to cross multiply. I get negative 4p equals 16. So p is equal to negative 4. What that means is that when I graph my equation, I'm going to go over 4 down to, that's where I'm going to start, and that's my vertex. I always put a V there or a P depending if I'm talking about a vertex or a focus point. So now I'm looking at my original equation right here. See how it's an x equals y squared, and in this case, it's actually an x equals negative y squared. It's an x equals negative y squared. What that tells me is that my graph is going to be shaped like this, right? So that means that my parabola is going to switch out like that. Additionally, from here, because my p is negative 4, that means I'm going to go negative 4, 2, 3, 4. That right there, that point at 0, negative 2, that's my focus point right there, okay? Find the focus point, we did. Just so you know, 1, 2, 3, 4. If I had gone 4 the other way, I wouldn't get a point there, but I would actually get this line right here. That's a directrix. And just so you know, we went over 4 and 4 again. So this equation of my directrix would be x equals positive 8. For problem number 13, it says find the equation of the parabola that has this as a focus point and this as a vertex. So let's graph it first. So if I were to graph my vertex over 1 up 2, so there's my vertex, okay, 1, 2. My focus point is 4, 2. So 1, 2, 1, 2, 3, 4, 2. So this value here is my focus point. I know that my parabola is going to cut my focus point. So it's going to look like this, okay? Which tells me that my graph is an x equals y squared graph. So therefore, my equation would look something like this. X minus h equals a times y minus k quantity squared. And this value right here, this a value is 1 over 4p. So p is this distance right here from my vertex to my focus. And that looks like it's 1, 2, it's 3. So that means that if my p is 3, then I'm going to plug that in right here. So I have 1 over 4 times 3, which is 12. So I have 1 over 12. Okay, so that value is going to go right here, 1/12. Okay. Additionally, that if my vertex is 1, 2, so then my final equation is going to look like this. X minus 1 equals 1 over 12 times quantity y minus 2 quantity squared. So that's the equation of the parabola in vertex form, called standard form or vertex form. Find the equation of the ellipse that has vertices 0, 5, and 0, 4 as my foci. So we're going to go 1, 2, 3, 4, 5. So at 0, 5, that's my vertex, 0, 5. I have focal point at 0, 4. So that's right here. So F is at 0, 4. Okay, so what that's telling me is, again, that my vertex, remember, cups my focus point. It's always going to be within the curve, okay? So that I also know that P is equal to 1 because this distance here is 1. Knowing that this is going down, it will become a negative 1 at some point. So let's make our equation. This is a y. If it was a y equals x squared graph, my graph would go up like that. But because my graph is a negative x squared, it will go down, and that's exactly what I have here. So we have y minus k equals a times the quantity x minus h quantity squared. We know that this value here, a, is 1 over 4p. Because p is negative 1, because we're dropping down, this is going to be negative 1/4 right here. My vertex being 0, 5, this is my x coordinate, my y coordinate, so I'm going to go y minus 5 is equal to negative 1/4 times x minus 0, quantity squared. So I would accept this right here as an equation for my in my parabola, or I would accept y minus 5 equals negative 1/4 x squared. I would also accept this equation, y equals negative 1/4 x squared add 5. So any of those would work as an equation in, this would be vertex form, these two here. This would just be an equation of my parabola, and that's all acceptable. This equation says, what is the directrix of this, or this question says, what is the directrix of the equation? It's a parabola. See that, 1x squared, 1 squared term. And generally when they're talking about a directrix, you know that they're talking about a parabola or a hyperbola. So anyway, I'm going to rewrite this. I have negative 8 times the quantity y minus 3 is equal to x plus 2 quantity squared. I personally like my equations to be with a x squared term on the right. So if it's a y equals x squared, it goes up. If it's a y equals negative x squared, my graph is going to go down. If my graph is x equals positive y squared, my graph is going to go to the right. If I have x equals negative y squared, my graph is going to go to the left. So in this case, I need to move this negative 8. So I'm going to divide that by both sides. And I'm going to get y minus 3 equals negative 1/8 times the quantity, x plus 2, quantity squared. So this, because it's a y equals negative x squared graph, that means that my graph is going to do this. Okay, graphing the vertex. The vertex for this equation is going to be xy. So it's going to be negative 2, 3. So we're going to go over 2, up 3. There's my vertex. Put your vertex in there. Also, I do realize that this point, right, this value right here, this negative 1/8 is equal to 1/4p. So cross multiplying, I get negative 4p equals 8. If I divide both sides by negative 4, I'm going to get p is equal to negative 2. So that means that this way, negative 2, my graph is going to go this way with my focus point right there. So that's going to be negative 1, 2, 3, negative 4, 1, 2, 3. So my focus is at negative 4, 3. And then my graph does that. My equation of my directrix, which is what they want, is going to be to the opposite direction, which is right here. Okay, so the equation of my directrix that pierces through x is going to be x equals at 0. So the equation of my directrix is x equals 0, and then answering the question that they asked. For number 16, it says, what is the equation of the hyperbola that is centered at the origin? So there's my center right there. And with the y-intercepts of plus or minus 3, and have asymptotes at y equals plus or minus 1/2. So what I have are y-intercepts of 3. So I'm going to go up 1, 2, 3, 1, 2, 3. So what this does right here is this tells me, because it has y-intercepts here centered at the origin, and I have asymptotes at plus or minus 1/2. So that means that from my graph, if I were to go up 1 over 2, up 1 over 2, up 1 over 2, okay? What that's doing is it's telling me, well, how would I get, if my y-intercept is 3, up 3, how am I going to get my y-intercept to look like 3 over 2 to make that a half? So what I would need is, this would have to be up 3 and over 6, because y equals plus or minus 3 over 6 x is the same thing as saying my asymptotes are at y equals plus or minus 1/2 x, okay? And so you could either go up 1 over 2, up 1 over 2, up 1 over 2 until you get there, or you can go up 3 over 6, and I'm going to get to the same exact place. What that tells me is if I'm going to the right or left 6 units, okay, that's the endpoints of my box here, but that also tells me this is my rise, this is my run. My run always is associated with my x coordinates. So that's telling me that so far we have x minus 0 quantity squared, we have y minus 0 quantity squared, underneath these values, under x, it's going to be 36. So because for me to go right and left, that's got to be 36. Underneath the y is going to be, that's 3, so this is going to be 9. We know this is equal to 1. We know that, let's see, it's centered, it has the asymptotes at 1/2. And what I believe that they meant by saying it has y-intercepts, because they didn't tell us one way or the other where my vertices were, I'm assuming that they're saying that actually my vertices are here and here. Instead of saying that my intercepts are there, they actually meant my vertices are there. But regardless, let me put in the asymptotes. The asymptotes for this box. So making this box like this, right? You would have a asymptote this way, and then an asymptote this way. Following the axis, this would mean that would be negative x, because my y coordinate for it to be my vertices would have to follow that like that, and this would go like that, this way and this way. So my equation of my hyperbola is going to be finally x squared over 36 negative plus y squared over 9 is equal to 1. And so that would be the equation of my hyperbola. I would also be able to write this like this: y squared over 9 minus x squared over 36 is equal to 1. You would, in a problem like this, you would need to also identify what the asymptotes were, and so we already did that. Another way of writing it would be this. You would also need to label where your focal points are, and so c squared is equal to a squared plus b squared. So we would say c squared is equal to 9 plus 36, which is 45 again. We did one like this already with 45. This makes that 3 root 5 plus or minus. And so therefore, because my graph is in the positive y, on the positive y, I would add those values to my y-intercept, add those values to my center, which is at 0, 0 at the origin. So my points would just be 0, 3 root 5, and they'd be 0, negative 3 root 5. Okay. So that concludes the second part of this worksheet. That we went over the problems that were on the worksheet for the Conic review. Stay or watch for another video that I'm going to be putting out that's going to be reviewing conics based on the slides that you would have seen in class. All right, thanks for watching, and I hope that helped.